Monomials are expressions with only a single term. These are some of the examples for monomials. Factors of monomials are the smaller individual terms that can be multiplied together to form the original monomial. Let's take the first example. 6a. The factors of 6a are 2, 3 and a. When you multiply 2 into 3 into a, you get 6a. Next, we have 8x square y. This expression can be written as 2 into 2 into 2 into x into x into y. So the factors of this expression are 2, 2, 2, x, x and y. Next example, 15a cube b square c. Here the coefficient 15 can be written as 3 into 5. A cube is a multiplied 3 times. B square is b multiplied 2 times. We also have a single c. This means the factors are 3, 5, a, b, b and c. Final example, 9y square z cube. The factors of this expression are 3, 3, y, z, z and z. With this understanding, let's move to find the GCF of 2 or more monomials. First example, let's find the GCF of 6a and 12a square. First, we list down the factors of both these terms. 6a has the factors 2, 3 and a. 12a square has the factors 2, 2, 3, a and a. Now, let's mark the common factors. 2 is common. 3 is also a common factor. A is also common. Now, the GCF is the product of these common factors. 2 into 3 into a, which is 6a, is the GCF of the two given expressions. Next example, 8y square z square and 12y square z. First step, we list down the factors. 8y square z square has the factors 2, 2, 2, y, z and z. 12 y square z has the factors 2, 2, 3, y, y and z. Next, let's mark the common factors. Then find out the product of these common factors. 2 into 2 into y into z, which is 4y square z. This is the HCF of the two given monomials. Here, there's an easy method to find out the GCF faster. We'll write the factors only for the coefficients. Find the common factors and write its product. Then moving to the variable part. Let's compare the similar variables y square and y square. So let's write y square as it is in our answer. We also have z square and z. In the second term, it means z to the power of 1. Here, if we have two different powers, we have to consider only the smaller exponent. In this case, z to the power of 1. So, our GCF becomes 4y square z. Moving forward, we'll use this method to find the GCF. Next example, 15 a cube b and 25 a square. Let's factor only 15, which is 3 into 5. The following term, 25, is written as 5 into 5. Comparing, we have 5 as a common factor. Moving to the variables, a cube and a square. We'll choose the smaller exponent, which is a square. Next, it's interesting to note that b is found only in the first term. So, it cannot be a common factor. So, the GCF for this example is 5a square. Next example, 21 x square y cube and 28 x cube y square. The first expression can be written as 3 into 7 into x square into y cube, and the second term becomes 4 into 7 into x cube into y square. Comparing the coefficients, common factor is 7. Then we have x square and x cube. So we'll pick the smaller exponent x square. Further, we also have y cube and y square. So we'll pick y squared. Now our GCF becomes 7x square y square. With that, we move on to our final example. Let's find the GCF of 3 monomials. 36 a to the power of 4 b square c square, 48 a square b to the power of 5 c square, and 12 a square b cube. Here all the 3 coefficients are multiples of 12. So we can write their factors as 3 into 12, 4 into 12 and 1 into 12. Here the common factor is 12. Next, we have a to the power of 4, a square and a square. We'll pick the smallest exponent, a square. Moving on, we have b square b to the power of 5 and b cube. The smallest among these is b square. We then have c square and c square. But in the last monomial, we do not have any c. This can also be considered as c to the power of 0, the smallest of all. So, we'll consider c to the power of 0 in our GCF. C to the power of 0 is 1. So, our GCF is 12 a square b square. If you found this video worth watching, give it a like and share it with your friends. Thanks for watching.